In our previous episodes with Passport, we've set up a way to verify that a user is who the user claims to be. We can log users in, keep them away from pages that require them to be logged in, and we even convinced ourselves of that via Firebug in the Node console. While Firebug in the Node console won't pacify our users much if nefarious actors are still able to pwn their data in our apps. In this episode, we're going to ensure that our users have the permissions they're claiming, and we do that with a package called Authorized. This page that you're looking at shows a mighty battler that our user a/er at learnallthenodes.com has created. If a/er wants to, a/er can edit Zeltar's name like you've seen here. Ooh, but watch this. In this other browser window, it turns out that Incognito does have legitimate uses. We have our user Nefarious at learnallthenodes.com who has figured out the character ID for Zeltar and uses a little Firebug magic to tweak the form. Now Nefarious types in this Hacksword character name and submits, and look at what happened. Even when a/er reloads the page, the damage is done. This is bad news. So it's obviously not enough to just hide actions that users shouldn't perform. The first rule of web programming is never trust the client, and in this case we got bit. Because Node/ is such a popular site and loot thievery runs rampant, we want to protect our users and preserve their entertainment value. Whereas up to this point we've solved the authentication problem, we still have an authorization problem. Enter Authorized. Authorized is a Node module that makes it easy to declare simple and meaningful rules around user authorization. It operates around three concepts, namely roles, entities, and actions. Let's explain them in reverse order. Actions are what we're trying to finally build to. These are simple statements that explain when a user can take a certain action. In our case, we want to be able to have a nice rule for ourselves that will dictate whether or not a user can modify a character. The business rule is that only the character's owner can do that, but we haven't written that in code. Next, entities are an authorized construct that will make fetching the current data that we're acting on easier. Back to our case, we're editing characters, so we would make an entity that fetches the character that we're operating on. Lastly, we have the roles. Whereas entities fetch objects from our database, roles are where we actually define our permissions. Let's see this in practice. Of course, we have to install Authorized first. npm makes our life so easy. This installation is as simple as npm install --save authorized and a little bit of waiting. Now we need to define our authentication rules somewhere. Let's make a new directory, app/authorization. Into this directory, we open a file that we'll call accesscontrol.js. First, and you may have guessed this, we need to access the module. We're a bit backwards here, but we're going to define our action first. These won't actually run until we've defined our roles and entities, but I think it's more useful to think in terms of the result we're trying to achieve. We want to lock down character modification to character owners, so we define what you see here. Let's break this down. First, we're calling the action method on auth, which means that we're defining an action. The first argument is our name for the action. We could put any string we want in there, but we're choosing to put in a descriptive name. The second argument is an array of strings, and in here we list out the roles, that we haven't defined yet, that will have permission to modify a character. This is why actions have to be declared last in our file, and they will be. So we're saying here that only character owners will be able to modify characters. Let's figure out what defines a character and a character owner. On to our entity. Our entity will make fetching our character a snap. Let's start with the shell. We call entity on auth, and our first argument is the name of our entity. Now this doesn't have to match the name of our model, but in this case it makes sense to. The second argument is a function that is capable of loading our character from wherever we have it stored. This is just like Passport's deserialize user. Remember that Passport hooks up the plumbing between a lot of functions that we define. Authorized does the same thing. We're giving it the pieces it needs to work. In our fetch character function, rec is the same request object that we'll later see in our route handler. Now to actually fetch our character, we just need to load it from the database, which means that we need access to the character model, so we'll grab a reference to that outside our entity. And then we can just use that to find the character. Find by ID is a function that Mongoose provides on all models. It's pretty obvious what it does, but it's worth noting that it'll work with either the string representation of the ID or an actual object ID object. Next, we give it the ID of the object that we want to find, And since rec is just the same request object that we'll see later in our route handler, we just grab the ID off the params of our request. Finally, it takes a callback with arity of 2, where the first parameter is an error object and the second is the record that got returned. It just so happens that this matches the signature of CB, which Authorize will pass to us, so we'll just use that directly. Next, we get to actually define the role. We're laying down so many skeletons, you'd think we're playing Diablo, but we're not. We're playing node/. There may or may not be skeletons. Again, we're calling a function on auth, and this time it's role. The first argument is again a string, and its format is entity.role. The first part of this string needs to match the entity we defined earlier, since Authorized uses that to know how to look up the entity in question. Now have a look at the function we pass. Its first parameter is record. In our role name, because we put character before the dot, Authorized is going to look for an entity called character to supply us with that record argument. Since we define that entity to look up a character instance, record will be a character instance. The second argument is again our request object. And lastly, we have a callback. This callback takes an error and a boolean. Basically, it's how we say whether or not that for this request context, operating on the supplied record is allowed. So let's define how it's allowed. It's quite easy for us if we have a look at the character model. I didn't put this model into the episode because it's some pretty vanilla Mongoose code, nothing fancy going on here. Notice that we store a reference to the owning user in the model. Let's see how simple this makes life for us. We just call the callback like this. If the current user's ID matches the character's user ID, then the current user is the character's owner and we're good to go. Notice that we're calling toString onRecord.userID. ID is a convenience function that Mongoose gives us to get a record's ID as a string rather than as the native Mongo object ID type. However, user ID is a native Mongo object ID, so the strict comparison would fail. We need to convert it to a string to make the comparison meaningful. I have been bitten by this so many times in the past. Now all this is well and good, but we need access to this code. So let's put one last line in this file at the very bottom. Next, we need to expose this to our app. So in config application.js, we'll attach it to our global app object like so. We just scroll down to below our definition of app and add it in via a require statement. And now we can actually hook this up for usage. We open our routes file and use what we defined. We first need to add a parameter to our wrapping function, so change the opening function definition like so. And then we need to make sure that we're passing in auth via config application when we bootstrap our routes. Now we can close config application.js and actually apply this to our routes. We can see from the documentation that auth provides a can function to us, which returns a middleware. We just pass the name of one of our actions that we defined. So on our update and edit routes, we'll take advantage of that like so. And then we just add that middleware to the routes in question like this. If you remember, we can chain several middlewares, one after the other, and that's all we're doing here. If the authorization check fails, then the supplied middleware will introduce an error into the queue, preventing our route handler at the end from running. And we probably should deal with that case, so we need to define one more middleware. Let's create app middlewares notauthorized.js, and we'll put in it a simple function. We need access to authorized because we need an error type that it defines, namely unauthorized error. Error middlewares take turns responding to errors, and we need to make sure that the error we see is one we care about. If it is, we treat the hacksaw to an unfriendly message because, well, the hacksaw was cheating. If it's not our error, then we just toss it along to the next one in the chain. And then we just plunk it into config application.js after our other middlewares, like so. Okay, so we need to restart our server, then we can see this in action. First, let's observe that a/er can still edit a/er's character, setting the name back. Now, when Nefarious tries to modify the character, let's see what happens. Nefarious gets back to Nefarious' own character, then doctors the form on it, inserting Zeltar's ID, and boom, stopped. And our players feel safer in their data, and we shed small tears because we didn't charge $25 for this service like the purveyors of a certain wildly successful MMO do. Let's quick have a look at those log statements we put in to see how execution flowed. Just like we'd expect, authorize first calls our entity that we defined. Once it has that, it's able to use it in the role we defined, and that's how it knew which user was legit and which wasn't. Even though one of our users was legit, it's still time to quit. There are lots of ways to handle authorization, and it can be done without use of a third-party module. What I really like about Authorize is that we can define the rules that determine what is allowed and what isn't, and then refer to them with meaningful, human-readable strings. Now when we read our routes file, it's quite clear what is going on. I don't think that would quite be the case if we just had a series of if statements littered in our route handlers. A really good exercise you could do to cement your learning here is to create a route that would delete a character and make sure that it only allows the character's owner to do so. Give it a shot, and if you get stuck, ask questions in the comments below. Until next time, happy coding.